Good evening, students. So last class we have discussed about the Markovnikov rule, right? So now we'll see the types of chemical reaction alkane which undergo. Okay, alkenes and alkynes will undergo addition reaction. So addition reactions are nothing but when you are adding a substance to the reactant, it will add it. Okay, so the unsaturated become saturated. So in the first we'll see that reaction and then mechanism one by one. So the chemical properties. Of alkenes. Yesterday I told you what is symmetrical, what is unsymmetrical, right? Say yes or no.
Sir.
So first addition reaction. When you take unsymmetrical or symmetrical alkene treated with hydrogen in presence of Raney nickel under 473 to 573 Kelvin. So it gives R CH2 CH3 higher alkene alkenes. From alkenes to alkanes is the product. So this is one type. This is hydrogenation. The name of the reaction is hydrogenation. And then bromination. So bromination is same alkenes in presence of Br2 in CCl4. It will give R CHBr CH2Br. That means hydrogen and perfectly. Okay. So this is the bromination. Instead of bromine, you can have the chlorine also. So the reactivity order of halogens, that would be chlorine will be faster rate than bromine, which in turns more than iodine. Okay, so this is now we are moving for the hydrohalogenation. That means HX. That means HX.
Recording in progress.
So hydrohalogenation, when you are adding RX, so R CH double bond CH2. When you are adding HCl, so the HCl can be ordered like this, or CLH can be ordered like this. Okay, we have two variety among this. We will get R CH CH3 and Cl over here. So the order of order of reactivity would be hydrogen iodide undergo faster rate than bromide, then chloride, then fluoride. Okay. So now, in this case, when you are taken alkyl iodide, sorry, unsymmetrical key alkenes, when you are adding hydrogen iodide, hydrogen halide is governed by Markovnikov rule. It will be done by Markovnikov rule. What is he said? Why is said? That we have to know. When you treat the unsymmetrical reagent, for example, hydrogen halide, unsymmetrical reagent and unsymmetric ketone, hydrogen halide, sulfuric acid, hypochlorous acid, add to the unsymmetrical alkene. So the negative part of the reagent is added to the carbon atom of the double bond, which bear added to the carbon which bear least number of hydrogen atoms. Okay, so now you look this is the Markovnikov rule statement. When you are having R CH double bond CH2, you are adding hydrogen HX. So H plus and X minus. What is the statement said? The negative part added to the least number of hydrogen atom. So look here, you have RCH double bond CH2. Here two hydrogen is there, here one hydrogen is there. So the negative part come to this place or this place. Which one? Middle one or terminal one? Middle one or terminal one? Where it will go? Where it will go, ma? This H plus and X minus. The X minus where it will go? This is the statement. The negative part of the reagent added to least number of hydrogen atom. Which is the least number of hydrogen atom? This one or this one? Which one? CH or CH2? So you have to look across the carbon-carbon double bond. If the carbon-carbon double bond having least number of hydrogen, there you have to add the negative part, because you will not say, okay, I will say, you keep it in your mind. So when you have carbon-carbon double bond, here you have to add the negative part in the least number of hydrogen. Here you have one hydrogen, here you have the two hydrogen. So the negative part will come to this position, and the positive part will go this position. When you are seeing the mechanism of the reaction, that or CH double bond CH2. We will take an examples of 1-propene. When you take the 1-propene, you are going to add the HBr. So first, the H plus ion will attack. So when the H plus ion attack, so either it will go like this or it will go like this. So we have the two types of carbocation. Okay. When that, if it goes like this, then it will give CH3, CH plus, CH2 minus. This CH2 minus will take the H plus, then it become CH3. Okay. Suppose if it is go as like green, it become CH3, CH2 minus and CH2 plus. So what will happen? This minus will take the H plus, this become CH2. So CH3, CH2, CH2 dot. Now you look at carbocation. It's a primary carbocation because the carbon which bear a positive are attached with one carbon. It's a secondary carbocation because the carbon which bear a positive charge, which was attached with two carbon atom. So now, if you are looking the stability of the carbocation according to the methyl inductive effect, so inductive effect and hyperconjugation can combinedly explain that the methyl group will be the plus I group. So the plus I group present, it increases stability of the carbocation. According to that, the tertiary carbocation will be more stable than secondary, which in turn more stable than primary, then methyl carbocation. This is the order. So among the two, which is the most stable? This will be the most stable. More stable. So most more stable. Because it's a secondary carbocation. It will be the least stable, less stable. Now, this part will take that Br minus, it will give CH3, CH3, and then Br. When it attach with Br minus, it will give CH3, CH2, CH2, Br. So it will be the minor product, it will be the major product. Because of the carbocation stability, it will explain. This is the Markovnikov rule. So when an unsymmetrical reagent is added to unsymmetrical alkene, then the negative part of the reagent is added to the carbon of the double bond, which bear least number of hydrogen atom. This is called as Markovnikov rule. Suppose same alkene anti-Markovnikov reaction. Same alkene you take CH3, CH double bond CH2. Okay. When you are adding hydrogen bromide in the presence of peroxide H2O2, it will give CH3, CH2, CH2Br. Okay. So this is known as anti-Markovnikov addition. Okay. Why the anti-Markovnikov addition occur? Otherwise, it is called peroxide effect or crash effect. Okay. So now it's called anti-Markovnikov effect or anti-Markovnikov reaction. Okay. Now we'll go the reaction. When the hydrogen peroxide is present, it will give the radical. How? It will cleave like this. It will give 2HO dot radical. So when there's a mechanism, okay, step 1. When it goes to step 2, HO dot will take, when you have having HBr, no, H and Br. So it will cleave as like this. It will give H2O plus Br dot. And the step 3, you are having alkene CH3, CH double bond CH2. When you are adding Br dot, so you will get two different products. Number 1, it will go here, so it will cleave like this. When it cleave, it will give CH3, CH dot CH2 Br. Another one, CH3, CHBr and CH2 dot. So you know that it's a primary radical, it's a secondary radical. You know that secondary radical is more stable since that methyl group in the methylene group will hyperconjugately stabilize this radical. Here you have only one hydrogen, it will stabilize that molecule. So more number of alpha hydrogen can stabilize the free radical. So we know that the stability of free radical, tertiary radical is more stable than secondary, which in turn is more stable than primary, then methyl radical. This is the order. Now, this is the third step. No, when it goes to the fourth step, what will happen? When you have this, if you're adding HBr, it will give CH3, CH2, CH2Br. It's a major product. Look here. Here you are getting the branching chain as a major product. You are getting linear product as a major product. Okay. Only the peroxide alters the mechanism. Okay. So when it treated with HBr, it gives CH3, CHBr, and CH3. It's a minor product. So what is the difference between anti-Markovnikov and anti-Markovnikov? When it goes to Markovnikov, so when unsymmetrical reagent, you are added to unsymmetrical ketone, the negative part of the reagent, which will go to the carbon double bond, across the carbon double bond, the carbon which bear least number of hydrogen. This is Markovnikov rule. When it comes to the anti-Markovnikov rule, the same thing, you reverse it. When unsymmetrical ketone added to unsymmetrical reagent, the unsymmetrical reagent added to unsymmetrical ketone, so the radical, the attacking agent will go to the carbon which has lesser number of that other part other than hydrogen, will go the part which is having more stable free radical. So it will give like this. So this is called anti-Markovnikov product. So same thing when the reactions combine with the corn sulfuric acid. So when your propene CH3, CH double bond CH2, when you are treating this with the sulfuric acid, it will give CH3, CH OSO3H, and then CH3. This is known as isopropyl hydrogen sulfonate. Same way when you have ethylene treated with H2SO4. It will give CH3, CH2, HSO4, ethyl hydrogen sulfonate. When the isopropyl methyl sulfonate is there, no isopropyl hydrogen sulfonate, when you are hydrolyzing, it will cleave this. It gives CHO3, CH, CH3, OH. Look here, when you have the group here, so what happened if you take the water molecule HOH, it will cleave like this. So the hydrogen will be added in the carbon which contain more number of hydrogen. The hydroxyl group is added to the carbon which contain less number of hydrogen, or the negative part of the group which will attack in the carbon which has the less number of hydrogen. So this is called hydration in the presence of acid. Hydration in the presence of acid. So this is the addition reaction with respect to sulfuric acid. Same way you can have addition of water. You take an example, that is when you have isobutene. If you treat water, the hydrogen will be added to the carbon which is having more number of hydrogen. See, look here, this carbon doesn't have the hydrogen, but this carbon have two hydrogen. So the third hydrogen will go here, and it will give CH3C, CH3, CH3OH. Because this carbon, when the positive part goes here, no, it will generate a tertiary carbocation. So the tertiary carbocation is more stable than the secondary one. That's the reason why it will undergo addition over here. And then oxidation reaction. So when you take ethylene, so the oxidation reaction with Bayer's reagent. Bayer reagent. So what is Bayer reagent? It's a alkaline KMnO4. So when the ethylene is treated with alkaline KMnO4, so the alkaline KMnO4, water plus oxygen, that's it. Okay. So 1% KMnO4. When you treat, it will give CH2OH, CH2OH. This is called hydroxylation. Across the carbon-carbon double bond, so you are added 2OH. This is called hydroxylation reaction. This is ethylene glycol. So when you take CH3, CH double bond CH, CH3. Same thing if you are doing with a 1% KMnO4, you'll get CH3, CH, CH, CH3, OH and OH. It's got cis glycerol. Okay, cis glycol. And then with acidic KMnO4 or hot KMnO4. So above one is basic. Okay. Now if you are using acidic, what you will get? When acidic KMnO4 use, this will be cleaved. It will give, so this part will cleave, then it will give RCH double bond O. Okay. Remaining will be combusted, it converted into carbon dioxide and water. So when you take ethylene in presence of oxygen, that means acidic KMnO4 or hot KMnO4, it gives carbon dioxide because it will give the formaldehyde. When you are here oxidizing the formaldehyde, it will be aerial oxidation take place. It gives the formic acid. If you are heated, that formic acid gives the carbon dioxide and water. That is the reason why. So suppose if you are using butane, when you are oxidized, will give acetic acid. So first it will give acetaldehyde, aerial oxidation takes place, and then it will give the acetic acid as a product. And the final another reaction is ozonolysis. So we know that the ozone will be considered like this, or some other case it will be different in structure. When you are added the ozone across the carbon double bond, okay, so the one oxygen will go over here, another two oxygen will go like this. So it gives the bond will be cleaved. Then it gives R CH CH2 will bonded with O. It will bonded with O. It will bonded with O. So the bond is cleaved. It will give the ozonide. So this ozonide, when you are hydrolyzed using zinc and water, the zinc metal will cleave the ozonide. At low temperature, it will give. So what is the product? R CHO plus CH2O. That CH2O you can have C formaldehyde. When you have the terminal alkenes like CH2, it will give the corresponding. If it is a methyl group, it will be ketone. When if it is hydrogen, you will get the aldehyde. If the compound have only one hydrogen, you will get the aldehyde. So this is called ozonolysis reaction. And finally, you have one more reaction, that is polymerization. So polymerization, you know very well. Polymerization. So in the ozonolysis, what if double bond CH2 is ending, you will get formaldehyde. If you are double bond Cr2, you will get ketone. Okay. So your overall, the formation of ozonide followed by hydrolysis in the carbon-carbon double bond by two carbonyl groups. So you can create one carbonyl and another carbonyl. Two carbonyl groups you can create. So the based on the ending group also, we can decide whether aldehyde we will get or ketone we will get. If the ending, the carbon which connected double bonded to the other carbon, if the group you are having one nitrogen on this any of that group, you will get the aldehyde. If you are not having any hydrogen, you will get the ketone. So this will be the logic, the main of the reaction. When go to the polymerization, the process which with a simple molecule combined to form large molecule is called polymerization. So you take in a wall, you have bricks and then one full wall. So the full wall is made up of with the bricks only. So the brick is the monomer, another is called polymerization. At certain temperature and pressure, so the monomer will undergo polymerization. The polymerization also cationic polymerization, anionic polymerization, free radical polymerization. The types will go like as like addition substitution reaction. The only thing it will form the polymer, it have the different property. That's why we are doing the polymerization. So starting a monomer and ending with the polymer. So the polymer used as plastic, rubber, and then many industrial important products. Okay. Suppose if you are having ethylene, you are treated with temperature and pressure. It gives N number. It's called polyethylene. Suppose if you are having propylene, heating, temperature, and pressure, it gives polypropylene. Polypropylene. So when you are using polyethylene chloride, you will get the polystyrene. For example, styrene if you are using polystyrene. If you are using vinyl chloride, CH2 double bond CHCl. This is vinyl chloride. You will get polyvinyl chloride, that is PVC pipe. CH2 CHCl n times polyvinyl chloride. Same way when you have styrene. So if you are heating, when you are doing polymerization, you will get CH2, CH and C6H5 n times. This is called polystyrene. And then if you have the Teflon, CF2 double bond CF2, under heating pressure you will get CF2 single bond CF2 n times. This is called polytetrafluoroethane. Okay, Teflon. This is called Teflon, what we are using. Okay. So general reaction I will write for the alkene. When you have R, C double bond C, or that R may be hydrogen, anything. Okay. When it undergoes the reactions like alkaline K monomer, the product is, you will get R, C, R, C, R, C. It become OH, OH. So cis 1,2 diol, and then it go when you're adding HX. So it based on that, it will give R, C, R, C, R, R. So one side you will have the hydrogen, other side you have the oxygen. And then if you are treated with ozone and zinc plus water, two-step ozonolysis, it will give R, C, R, double bond O. So twice of the molecule, you will get it. Okay. Suppose if you are treated with water and sulfuric acid, that means hydration, you will end up with R, C, R, C, Okay, so we will get the hydrated product. So if you are doing the reaction with hydrogen per platinum or palladium or nickel, so hydrogenation will undergo, it will give R C R C R R one side, hydrogenation. Suppose if you are doing the reaction with halogen in CCl4 or ether, that reaction is known as halogenation. When you are doing so, you will get R, C, R, C, R, R, and XX. So this is known as, so the reaction name of the reaction is halogenation, hydrogenation, hydration, ozonolysis. So it has many important applications. You will get the all get to know. Hydro halogenation, Bayes test. Okay, so this is what happened in the your alkane. So same as like your alkene, alkanes also undergo this type of reaction. What is alkynes? When you are coming to that next topic, alkynes. So when the alkynes, you have the general formula CnH2n minus 2. The name should end with YnE. It has carbon-carbon triple bond, and then it's the unsaturated system. So in the IUPAC name, alkane minus ANE plus YnE. So it become alkynes. So the method of preparation of alkynes, we'll see. So in the laboratory method, when you treat calcium carbide, when you treat the calcium carbide in the presence of water, it will give acetylene plus calcium hydroxide. And then second method, when you have alkyl bromide, so if you are treated this with sodamide and alcoholic KOH, it will give acetylene plus sodium bromide plus water. And the next one, when you have the any group which has the hydrogen from tetrahaloalkanes, and have the tetraalkanes, if you are using zinc dust and then heating, it will give R CX double bond CX hydrogen. Okay, again it will treat with zinc dust, the same thing, it will give R C triple bond C R. Okay, so here it is very important that the 4 halogen atoms should be in the vicinal position. Okay, so what are the physical property? They are colorless and odorless, tasteless. So low alkynes are particularly soluble in water due to their polarizability. So higher alkynes are insoluble in water because of the more covalent character, completely soluble in organic solvent. Okay, so the boiling point and melting point directly proportional to molecular mass and inversely proportional to number of branching, same as like with alkanes and alkenes. So up to C4 carbons 4 carbons, they are gas, 5 to 11 liquids, 12 to and above solid. So acetylene and 1 alkynes are acidic in nature due to presence of the active hydrogen at the terminal carbon. So the order of solubility, density, and melting and boiling point. Generally, the alkynes have the higher density, higher boiling point, higher melting point, and acidic character than alkene, which it turns more than the alkanes. So when you are seeing the chemical property, so the acetylene which will have the acidic hydrogen. So when you have the carbon-carbon triple bond connected, if you have the hydrogen, this hydrogen will be acidic hydrogen. These two hydrogens are acidic hydrogen. Why the acidic hydrogen? Because it readily react with the base, it will form the solid. For example, so chemical property. When you have acetylene, CH, triple bond CH, when you treat with sodium, it will give sodium acetylide plus hydrogen. Okay. Same with acetylene treated with sodamide NaNH2, it will give sodium acetylide plus ammonia gas. Disodium acetylide. So sodium acetylide. And then addition reaction. Same way, it also undergo addition reaction. Okay. So what are the reactions it will undergo that we will discuss. When you have the alkene, when you have the alkenes treated with HZ, so the HX or anything. Okay. So generally how the addition will go, you can have that halogen, hydrogen, and then hydrogen halides and water. How the reaction it will go. So when you are having HX, first you will add with the H plus, and the H plus is added mean, so any of the place it has to go like this, so it will give C, so double bond C, and hydrogen will be added, and then it will be positively charged, and the negative part is added, it will go. Okay, so this is how the addition will happen. We have one double bond. For example, addition of halogen. When you have CH3, C triple bond CH. Please remember this carbon, you don't have the hydrogen because 3 triple bond on one single bond. So when we are adding bromine over here, so Br and Br, so it will give CH3 CBr double bond CHBr. Okay, and then when you're adding again that bromine, so because of the larger size, the bromine will go trans. So addition will be trans. Opposite like எப்படி இருக்கும்னா CH3 C double bond C Br hydrogen Br. So this larger group will be the opposite. That's why it is called trans. Okay. So the reddish orange color of the bromine in CCl4 is decolorized. So because it has the carbon-carbon double bond. Unsaturation, it indicates the alkynes have the unsaturation. And then next reaction is addition of HX. Same way as like where Markovnikov rule, the addition will take place. So look here, CH3 unsymmetrical alkene, C triple bond CH. So when you take HX, according to that Markovnikov rule, the hydrogen will be added, carbon which bear a more number of hydrogen. So this hydrogen only. So you will get CH3 C double bond CH2X. Correct. This is the Marconic of addition product. So in the presence of HX, in the presence of H2O2, what you will get? CH3 CH double bond CH2X. Okay. So again you are adding HX. So the hydrogen will go, the carbon which have more number of hydrogen. So here only you have the more number of. So this will be the addition product. Same way, when you have the addition of water, when you are adding water, same way as like you are using mercury sulfate and sulfuric acid, and then heating, it will give CH3 COH. It will give double bond CH2. So if I now getting now, that will undergo tautomerization, it will give CH3 C double bond O CH3. So tautomerization. I will get the ketone as a product. Same way, it will undergo polymerization. Polymerization, brother. So when you have acetylene, you are heating red hot condition. Red hot condition, it will give benzene as a product. Okay. Same way, it also undergo linear polymerization when you are using cuprous chloride and ammonium chloride. It will give CH2 double bond CH single bond C triple bond CH vinyl acetylene. So like that it will give. So now we can generalize that as like our alkanes. Alkanes also you can generalize the chemical preparation and method of preparation. So CH2 Br Br CH2 CH2 Cl Cl. சும்மா உங்களுக்கு ஞாபகத்துல இருக்கிறதுக்காக அது மாதிரி. And chloroform iodoform CHI3 plus 6 Pag plus CHI3 twice the molecule. Okay, when you are heating this, all these will give only one. What is that? That is the C triple bond, sorry, CH triple bond CH. So what are the reagent we are using? Here you are using alcoholic KOH and heating, otherwise NaNH2 and liquid ammonia. This reaction is known as dehydrohalogenation. This is a heating with zinc dust and alcohol and heating. Here, this is iodoform with the silver salt. You will get the acid. Same way, வேற என்ன மெத்தட்ல இருக்குன்னா when you have fumarate, வந்து கோல்ட்ஸ் எலக்ட்ராலிசிஸ் பண்ணீங்கன்னா same way laboratory method la what you can do, you can have that calcium carbide plus water. Two carbon plus hydrogen. So by this way we can prepare. Now you are going to see the chemical properties. When you have acetylene CH triple bond CH. So if you want to prove the acidic character, acidic properties, you can treat this with sodium and liquid ammonia. This is called Birch reduction. When you're doing it, so you will get CH triple bond C Na plus half of the hydrogen gas will go away. This is called sodium acetylide. Okay, same way this will reduce silver nitrate and ammonium hydroxide. C triple bond C Ag Ag. It's a white precipitate. So cuprous chloride and then ammonium hydroxide. Same way copper acetylide will form. So red precipitate. And then it will give ammonium chloride. Okay. So then it will react with RMGX. It will give RH plus CH triple bond CMG MGX. So these are the acidic characters. And then CH triple bond CH. When you are treating with hydrogen and palladium, it will give CH2 double bond CH2. Again hydrogen palladium, it will give CH3 CH3 NX. Same way you are doing with the chlorine, it will give CHCl double bond CHCl. Again the same Cl2 with CCl4, same reagent, then it will give CHCl2. So vicinal halide you can prepare CHCl2. Same way when you treat with HBr, it will give CH2 double bond CHBr. And then if you're treating HBr, will give CH3 CHBr2. Okay. Same way when you treat this with hydrogen peroxide and boron, hydroboration in THF, it will give CH2 double bond CHOH. And then tautomerase will give aldehyde. Then it will go polymerization. So in the polymerization, it will give benzene cyclic polymerization. When it undergo linear polymerization, we'll get polyacetylene. It will become CH double bond CH, single bond CH, double bond CH, N times. Okay, these are the chemical properties of your alkynes. So tomorrow we will discuss about the benzene and their reactions, orthopara directing group, everything. Okay. Any doubts you may ask now. I think no doubt.
I don't have any doubts, sir.
Okay, we will close the class.
Thank you,
sir.
sir.
Welcome.